Alright, so next we will see what we are going to learn for this class. Like to give you some idea or some image on what the milestones are. So this class is called Introduction to Probability and Statistics. Interestingly, somehow they use the word probability first, because it's kind of more like the more important part. But what we're gonna learn first is we're gonna learn statistics first. And then we are gonna move on to the probability. And finally, we are gonna go back to statistics. So these two topics, or these two main topics are kind of going back and forth. Like statistics a bit, then probability, and then back to statistics. and first we are going to learn some introduction to statistics, like some normal terms and concepts like mean, median, like those things you might have seen or have learned already in the past, percentile, and other stuff. And there should be only one lecture 1 week. What we are going to see next week in lecture 2. Then we are going to learn this big topic, which is called the probability. It is the math part. Since I'm studying math, so that's the part I'm more confident in. And so this part it's gonna span for about 6 or 7 lectures, or less, or fewer, I guess. Let's say 5 to 6 lectures. Now the topics we are going to learn are including counting principles, whatever they are. You might not have heard of this word before, but we're gonna learn how to count. That sounds fun, I guess. Counting stuff, like counting without counting by using some rules or some formulas to speed time. You can learn some probability, the basic concept, and some probability in other terms, like conditional probability, Bayes theorem, and independence. Again, whatever they are. Let's next go. Then we are gonna learn what we mean by random. Like things are random, everything is random. If you play games or play cards or gamble, you will see randomness everywhere. But what is random actually, and how can we learn or study or quantify or make something, make it a meaningful definition? What we are gonna find out in lecture. Some specific random variables. Like these words are thrown everywhere. If you hear something is related to statistics or pretty much everything that needs stats, you see the word like kind of binomial. You may or may not have know what that means. Geometrics or Poisson. That's the name of the mathematician. Like whenever you see a name, a specific name, you kind of have a vibe that this must be important somehow. And so that's the probability part. And then we are gonna come back to statistics, divided into two main topics. First, we have the normal distribution. This is the bell curve, the famous or infamous, however you want to define it. It's the bell curve. It's a concept that if you have enough samples, or if you have enough data, it has some kind of requirements or criteria, right? It is random, regular, predictable, or some sort. Like then they are gonna have this kind of shape, this kind of distribution. Like, so that's a bell curve, the normal distribution. And finally, this is the application part. This is the application part, and this is kind of like the final boss, the main goal. We're gonna use everything we have learned in this class starting from this part and this part, to to make it something meaningful that we can use to help our judgment. When you have to decide on something that you are not sure, you are not certain what the outcome would be. You need to use these tools or these models to, give you some number used to make a big decision. That's pretty wide goal for the class. Don't worry, we'll go over each topic in once a week also. And oh yeah, exams. Are they hard? Yes. Let me know if it is too loud or hmm, that's too loud to me. Oh yeah, exams. We will see. We will see. Oh yeah. Any questions before we move on to some? Not 10. Yeah, let's play. Let me make sure that the link still works. Oh yeah, it still works. Okay, there's a office. First go to the link. Oh yeah, that's mine. That's mine. Get into the link. So if I have to start or do something with that. Oh, start. Okay, I don't have to assign that. Oh yeah, what's the screen? I think so. Yeah, wait for your friends. I guess. Yeah, please follow the link to Kahoot. Are you in? Oh wait, I should maybe I need to copy this link instead of that. This instead. They look the same. Oh yeah, yeah. I guess that that's not the right one. Please follow the new link. You should have the game pin 977154. Or alternatively, you can go to the app and put in this pin, or you can use QR code. And again, this is a not serious quiz. This not serious quiz. Just please join and have fun. I'm not gonna grade this quiz because you will see the questions are not serious. I think I can. Or maybe I shouldn't. Yeah. That's sound, but I believe you can hear voices on your phone anyway, right? In case. I'll start in a minute. Let me know if you are trying to get in, but there's some issue. Or there are themes. We are leaving. Anyone else wanna get in? We are starting in 5, 4, 3, 2, 1. Phew! Warm up quiz. Quiz. What is the class ID? Are we all in the right class? DD226, DD1, DD555? Oh, that was fast. Oh, only 2 of you answer. But that's too short. Oh, I can't change the time limit. But anyway, yeah. Seems like nobody got the right answer. That's tragic. Okay, let's move on. Ooh, we are our first place. Second, what is my nickname? Third, second. Who am I? Yeah, nice. 5 of you got it right. Oh, okay, that's also a time bonus. If you answer fast, you get more points. So no is in the first place. 1. Double points. One of the topics will not be covered in this course. Probability, statistics, logistics, distribution. Or cat. Oh, nice one. Oh yeah, this is not kind of half serious. Like the first 2 are in the title of the course, so of course we are going to learn that. But logistics is about, driving or traveling or moving stuff from one place to another. So what about this course? And we got this is this is the main concept about statistics, which is the distribution. And actually, what we see above, like this 0, 0, 6, 2, is what we call distribution. Okay, so it's kind of in this. So nice. Ooh, double the points. 26,000. Oh, that's close. Next. Fourth one. What matters least to succeed in this class? Happiness, paradise, perseverance. Yeah, not serious, but yeah, paradise. whatever that means. We kind of need practice, of course. We kind of need perseverance, because we are gonna stay here for 16 weeks. That's a long time. So kind of like mental strength to move on. Playfulness is kind of tricky. You are not wrong though, because it doesn't matter much, but but yeah, paradise is way off. Ooh, 35, 35, 32. Let's see if you can catch up. Oh, 4 failures have reached track 3. So you got 3. Number points. Are you feeling lucky? Are you feeling lucky? Ooh, not that lucky, I suppose. So yeah, one of you got it. Let's see who. And drum roll. Other one. The first place is Boss. Congratulations. Yeah, because you got the last one correct. You are the only one who got the last problem correct. Nice. But yeah, we're gonna see more of this later. Some class, not all. Yeah, it would be nice to have all classes. But we will see how we. Oh yeah, 0% correct on the first one, and only one person got it on the the random one. There's no reason behind it, just bottom left. But just one funny thing though. I tried this last year in a class of 20 people, and nobody got this one right. Somehow every single one of them dodged the yellow circle. So that's a funny coincidence. Difficult, of course. Yeah, so that's a nice break, I guess. Yeah, let's play. We play that. And then yeah, let's finish with some definition. You don't need to bring papers or pencils or anything else yet. I'm just going to throw in some random words or some random pictures and kind of like trigger or prompts you to think about something that you may have seen before already. All right, so yeah, statistics. Like that's a key concept here. Like because we learn two things, right? The two main topics in this class are probabilistic, probability, I suppose. Statistics. These two are kind of intertwined. Like they are two different topics, but they kind of rely on each other. Like to understand statistics, you need probability. Probability. Yeah, probability to to know the concept or to get the formula or to do anything meaningful. And then to study probability, you need some statistics to motivate. Or this is kind of like the math or the theorem or the problems. If you study too much, you will get lost or get drowned by the amount of materials. And so we need to get a glimpse or get a some kind of feature, I guess, like to know why we are doing this, why we have to calculate this number, why we have to roll dice. Whatever we do here, it will matter. It will be used in statistics. But again, what they are in the first place? Why do why we have to split them into two different topics when they're kind of the same, I suppose. I have this kind of, I guess, nice picture like on what we do here. And so we are doing two things here. Like in the first box, we have sorry, in the first image, in the top part, we have this green bucket. This is green, and let's say there's a lid on the top, so you don't see anything inside the bucket. But what you can do is you can put your hand inside the bucket and grab some pebbles and take them out and see what those pebbles are. In this case, you see kind of like 3 black pebbles or pebbles, 3 black pebbles, 3 white pebbles, 2 gray pebbles. Those are the contents what you got in your hand. And the question is, you want to like use the information you have, like this tiny piece of information, to make a guess or to deduce something about what the contents in the actual buckets are. Like how many pebbles are black, how many pebbles are white, what are the ratio between these two or these 3 colors. If you are doing this, you don't know the big picture, but you have only a small sample. This is what we call statistics. And this is common when you do some things like poll, where you have 10 million people to ask about some topic, and you can't ask them all, so you have to select some smaller samples to make a poll to ask the questions. But on the other hand, like sometimes you know the content of the bucket, you know everything already. You have all the numbers, you have all the maths. Right? But what you want to ask is, you want to ask what would happen when you again put your hand in that bucket and grab some pebbles out. And what can you say about the content in your hand? Would you expect to get like all black pebbles? Or maybe like 50-50? Oh, sorry. That's not the right color to use. Would you expect to use to see all black pebbles in your hand? Or would you expect to see 50-50 between black and white? Or anything else. If you have the picture, if you have all the numbers, like all the models, but you want to know what would happen if you take a smaller sample out, this is what we call probability. That's the math part. And you can kind of see from this analogy, from these 2 images, that they are kind of related. If you want to know the bucket, you need probability, like to kind of give you some information about what the whole bucket contains, and you also need some information or some idea from statistics to make a guess or to make some meaningful model on what would you expect to get if you grab some of the marbles out. Oh, pebbles, sorry. I keep switching between these 2 words. So that's the big picture on what the difference of these 2 things are. Then we have some definition of statistics. Just 2 lines. Just let's say a fun fact, I guess. Because the statistics, like the word is everywhere. It is often abbreviated to stat or stats with an S. And what it is exactly is the stat. I add in the region or the country. So the statistics or the statistics is a study on state. What do we study? We study the population. We want to count how many people are there. How many people there are in our country or in our state. And also some like economic information about the state, for the state, about maybe income or debt or loan or whatever, how much you spend. Now, those are the numbers that people who to govern the state want to see. Make a policy or anything. But nowadays we still use these numbers, but they are not limited to just the state. We use these numbers everywhere. Maybe use this number for, yeah, of course. Recently we have some COVID or epidemic that you may have heard about. We use that use statistics to to collect samples, to collect data on how many people are infected, how fast the infection rate is, and so on and so forth, and make it to to deal with it. Now we have we are more, let's say, more equipped. We have more knowledge and more advanced knowledge to study those numbers in more details. So nowadays it becomes a scientific method. It's a method that you can prove that has some exact sequence. It's a method that we use to analyze all the numbers, all the data, not limited to population and economic anymore. Yeah, anything related to business, and all the social and natural science. So again, fun fact, what that other state was before. And then we have, yeah, the usual poll or the usual election. It's the definition of the statistics. And here we have a problem here. When we want to know who wins the election in advance. Of course, because that may be useful information, right? But again, we're gonna have to wait until the counting of the ballots stop, when they finish counting everything, to announce who the winner is. But what we can do beforehand, like if you cannot go ask every person on the street, if you're gonna have to make a poll. You might take some samples. Let's say you want to take some random 100 people in your town and ask them who you're gonna choose or who you're gonna vote for in the upcoming election. You might be able to recognize these two faces easily. Trump, that's Biden. And we knew the result of the election, didn't we? Oh, yes, I forgot. I should put in the most recent one. It's the Bangkok election. And anyway, so we want to know who wins. But here's the issue. So let's say this box represents the people in the town. Each dot is each dot represents a single person, and the color represents who that person is gonna vote for. And you're gonna vote for the red person, or you gonna vote for the blue person. And you can see the blue analogy from this image. This is also the color they use for the liberal and what's the other one? Conservative. Yeah. Anyway, for the two sides of the election. Right. I mean, suppose we have this big box, and if you know what every single person we vote for, we can get a picture. We can predict who will win. Like in this case, the blue will win for sure. That's an overwhelming victory for them, like 90% blue. But it is possible. Like even there's this much blue, it is possible that somehow you pick a bad set of samples. Somehow you pick the people who are, who are red. Like that. Like what you see on the right. We have 500,000 people that are mostly blue, but somehow you pick 14 red and only 6 blue, which brings to only 30% blue. And this thing can happen. And there's no way to tell whether it's gonna happen or not. And if it happens, then you will see that there's gonna be some bad consequence, some disaster. Someone is gonna get fired from doing this. So the question is, first, how do we avoid that? Like, can we avoid this kind of mistake? Or maybe not mistake, but this kind of rare event. Can we avoid that? And second, if we happen to encounter that, then what can we do, or what can we fix that? Can we do something different before? Can we do something different better? Or can we do, some nice tricks, some ideas to make sure that we are not gonna be like this wrong. We are not gonna make some false or some bad predictions. So that's the issues that we see could happen. But the question is how we're gonna deal with them. So that's what it is, what we call the inferential statistics, and that's gonna be the second half of the semester. Right, next we have these are the questions. Like to avoid this kind of problem or this kind of bad consequence, we have to ask ourselves how to sample data. Or in this case, sample is a fancy word for pick. How we pick the data, how we pick each person. How do we make sure that we are not gonna get a bad, or in this case, the keyword is a bias. This set of data, this set of 20 people are biased. Too many people are red when they shouldn't. And so we need some procedure, some checklist to make sure that we don't make that kind of mistakes. And then how do we extract the data? Because usually the data is, just have a spreadsheet. You get some names, you get some numbers. But then what can we say about it? Can we make some conclusion? Can we see some patterns? Can we make it look nicer, look easier to interpret? And there are many ways to get those numbers out. And once we get them out, then we have to ask ourselves, how do you represent the data? Because again, the data is just a set of numbers. You can put everything inside a nice spreadsheet, and that could be the end of the day if you don't do anything about it. But of course, you can make some nice graph, some nice charts, some nice, nice bar, nice whatever. What kind of tools or what kind of let's say techniques you can use to make them look nicer, to make them more useful. Yeah, and then finally, how do we interpret the data? After we have all the numbers, after we have all the nice graph, nice presentations, we want to interpret, we want to see and say something about it, say something meaningful about it. And it's gonna be important when you are executive, or whenever you want to make some decision. This set of data will help you go in the right path. And so that's the main concept of statistics. That's the main concept and also the main concerns about statistics. And so that's the first. That's one half of the class. The statistics. Then we have the other part, which is the probability part. Like here, are you feeling lucky? Like what we just did in the quiz. There are 4 questions. You have to pick one at random. How likely it is that you're gonna pick the right answer. Oh, and interestingly, what we just did, display what the actual statistic should look like. And because there are 8 people in the quiz, and there are 4 questions. Oh, there are 4 choices. If you have no idea which one to choose, then you're gonna choose one at random. Maybe you want to choose A, or B, or C, or D, because again, you don't know. You have no idea. And so ideally, there will be 2 people for each choice, like for each option. And if it is really random, you should expect. That's the keyword here. We should expect to see 2 people for each choice or for each option. And what we actually saw is not too far off from what we expect. Like we see 3 in the first option. in the first choice, like in the option A. we saw 3 in the second choice on B, and then we see 1 for D and 1 for C and 1 for D. So these look pretty close to what we expect. Like they look pretty even, close to each other. Yeah, there's some difference because of course it is not always in this case, but this is close enough, like close enough to what we would expect to see. And then we're gonna make it a formal definition and see what we mean by that. Like what we mean by, oh, if there are 4 choices and there are 8 people, then there should be 2 people for each choice. It is kind of like intuitive to some of you, but it is actually not. You can see, okay, it's 8 over 4, which is 2. Yeah, but it is not as simple as that. And you will see why. And we will have to do homework and do exams on why that's the case. Oh, and yeah, all these pictures are what you would expect to see in class, in exams, in homework, or in everywhere whenever we mention the word probability. You're gonna see dice. That's our favorite to make a random number. See that in games everywhere. The cards. You may or may not have played this kind of cards. I'm not sure what people these days are playing. But I think I saw some students play Uno or some modern board game like Werewolf, Exploding Kitten. You seen that? Or does anyone of you have that game? Exploding Kitten. These are all the card games. But yeah, for this class, we're gonna use the standard poker set of cards. And yeah, we are gonna flip some coins. We're gonna buy some lotteries and see how this goes. That's what we mean by probability and how to make a number. And oh yeah, we're gonna see lots of vocabs. This is a math class, but lots of concepts require an exact term. The terms are maybe combination, permutation, and these are 2 random words. You don't need to know about them yet. We will learn about them together in class. What does that mean? These are the words that you should have heard at some point in your life, like odds, chance, probability, likelihood. These 4 words are kind of the same word. I mean, they have the same meaning, but we use them kind of like interchangeably. In one area, you may hear the word chance. In another area, you may hear the word odds. But I'm gonna try to stick with just one word, so it's not too confusing for you. And then we're gonna discuss what it means to be random, what it means to be fair or balanced, because these are the words you use every time you play any kind of game. Like, oh, everything here is random. Oh, the game is not fair. Oh, this is too OP, is imbalance. Like, we will learn a little bit what these words actually mean. Because in fact, some people doesn't use the word random correctly or even fair. Like sometimes you play 3 games and you get like bad result. You might complain that, oh, it's not fair. Get some bad heroes, like you get some bad cards, or I roll dice and I get low numbers. But in fact, 3 games are too short to decide whether the game is fair or not, whether the dice is loaded, whether you are cheated. So yeah, we will take a look and we will define the word fair. See together what it means to be fair or not. and some paradox. In these topics, like the topics about the topics on probability and statistics are full of paradox. And the thing is, there are topics that we can kind of understand, like because we can imagine, we can think of some examples of things we have seen or we have used or we have done before. So we have some basic idea, right? But the thing is, some of them are not intuitive. They are surprising. Maybe I should use that word instead. Something is something. Oh, okay. It's obvious. Like looking at these numbers, we believe that the answer should be this one. But in fact, if you do the math, you actually do the math, or if you use the right tools, then you can see that, oh, actually we are wrong. What we thought was correct, actually not what it seems. And that's that's why we get lots of paradox in this area. For instance, this is very, very popular questions in statistics. And if you study statistics or probability and you haven't seen this problem at all in your semester, during that semester, then that means you haven't learned probability at all. You need to know this one. You need to know this problem so that you can brag that, oh, I took the class already. So this is a simple problem. So there are 3 doors. It's not a door, but there's 3 doors. 1, 2, 3. Let's say, yeah, we close it. 3 doors. And behind one of these doors is a car. Oh, by the way, this is based on true story. And this is the actual game. The actual game show. Oh, not a game show, but yeah. Yeah, I think it is. So there's 3 doors. Like behind one of these doors is a car. If you open the door with a car, you can drive the car home. You get a prize, a big prize. One of these doors are just blank, nothing is behind. And one of these doors has a goat. And I think this is what makes this problem famous, because there's a goat, and the goat is cute, I suppose. But anyway, yeah, there are 3 doors. You open a door and the MC will tell you whether you win the prize. But the thing is, after you pick a door, let's say you pick the first door. The MC announced that, okay, you pick your first door. Are you sure? Do you want to change? Like, there are some dumb rolls and and anything else. Then the MC says, oh, actually, like behind the third door is a goat. Actually, there should be 2 goats. There are 2 goats. After you pick the first door, the MC announced that, oh, actually the third door has a goat. And then he asks you a question. Do you want to switch? Do you want to switch? And by switching, it means that you change your mind. You want to switch from the door number 1 to the other door. And because the third door has already been revealed to be a goat, so you can switch. You have an option to switch to the second one, to the other one. Right? Do you want to switch or not? You may switch and get the goat instead to get a car, or you may have chosen the goat in the first place. You could switch to get a car. You have no idea yet because those 2 doors are still closed. And the question is, should you switch or not? Would you get a higher chance to win a car if you switch to door number 2? Well, that's the question, right? And intuitively, it may seem that, oh, there are 2 doors, right? So it's 50-50. And if it's 50-50, then you shouldn't switch. Oh, it means it doesn't matter. It doesn't matter if you switch or not, because you have 50% chance to win the car if you stay on the first door you chose, or you also have a 50% chance to win the car if you switch to the other door. Right, but of course, that is exactly what I just told you. Like that, oh, the first thing that came to your mind, like the thing that seemed intuitive, that seemed correct, is actually wrong. And the answer is you have higher chance to win the car if you stay. The answer is you should stay. And why should we stay? Like, why does it matter if we stay or not? Like, that's the topics for another day. Week 4 or 5. But yeah, don't worry about that yet. But just at least see that sometimes it doesn't seem that simple as we thought it was. That's a simple question number 1. I think I have 3. Oh, true. And there's the second one. Like, is this called the birthday paradox? And this one is very nice because again, you can click on the link. Whenever you see the green text, that's the link for you. I'm gonna copy the link. I can't. I have to click on the link. Put on the link and you put that into Teams. So this one is an interactive exercise, I guess. Oh yeah, interactive experiment. Let me zoom it in a little bit. So I'm not gonna go through all of this, but I recommend you try this after we finish this class. Yeah, because we're gonna finish in like 5 minutes. Like we are not gonna go through the whole length. But yeah, I highly recommend you finish this whole experiment or this whole interactive course instead. Right, so if you come here, like the birthday paradox, oh, lots of balloons. Click on, let's do this. Put in your birthday. That's you. That's wrong. It's the beginning of the year. Please tell me your real birthday. This is for science, not evil, I promise. Then, okay, that's my birthday. Cool, thanks. My birthday is November 15th. Yes, that's the author, the person who made this website. We don't share the same birthday. Oh, that's sad. Anyway, but the question is, how many people do you think we need in a room to have 50% chance that 2 people have the same birthday? Long sentence, so let's break it down. Like, how many people do we think we need? So you can think of, a number of people like 5, 10, 20, 100, 300. How many people do we need to have 50% chance that 2 people have the same birthday? So for now, there are only 2 people. So it is very unlikely that these 2 people are gonna share the same birthday. Like, because there are 366 days in a year. So it is not likely at all that we both or these 2 people gonna share the same birthday. But the question is, how many people? And you can, but you have to. You have to pick up this yellow dial and move it. Do you think we need 365 people? Do you think 2 people suffice? Or do you think about something between maybe 180? Maybe slightly lower? Anyway, yeah, I recommend you do this after the class, which is in 5 minutes or so. That's a fun one. Oh, I think that's a homework, maybe. No, it's not. Right, and finally, like we have some kind of a roadmap. And at the end of the semester, when we take a final exam, of course, this is the image of what I want you to have in mind. It's actually have everything, almost. Oh yeah, of everything that we are gonna study in this class. We have the sampling, which is the question or the method, the procedure, how we can take a sample and pick people from a large population to make a poll or to ask questions. And then we need some kind of statistics to get some interesting or to get some meaningful numbers out. The center, the spread. You see that, oh, you can make some nice graph if you want to. Then we're gonna have to learn some probability, some math, to know what kind of tools or what kind of concepts we need to use. And once we have learned that, then we can move to another branch of statistics. Then we can use that area or that method to make some estimation and we can test our hypothesis. And finally, everything will boil down to decision making. So the reason we do all of this, the reason we study math, we get all the numbers, we use some apps or softwares, is that we can use the data we have at hand to make a meaningful decision. For instance, if you are a YouTuber, you see the amount of people who subscribe or watch your videos. You want to know whether you need to hire more people to make a full-time video careers, or do you just keep it a hobby forever? Is worth it to go all in and make it a business, a serious business? Or if you are in a government and you have to make a policy about COVID based on the information, like based on the number of people who got infected or people who have vaccines or other stuff, like how many people should we pay? Should we order more vaccines or more medicines, or should we expand hospitals? Should we make a lockdown? Should we close the country? Other policies in the final decision. Everything is based on the data and the numbers and the statistics. Yet in the end, and so that's the final goal. If at the end you see this image, you see this picture, and you understand each part of what they are and why we need each of these parts together, then I'm gonna be happy for you, I guess. Or I should say that means you are successful in this class. Okay, so that's the end of the class today. We pause that first.